Hello
Welcome
everyone.
everyone. This is ICP10 and here we are dealing with the Cipher10 dataset. So the first step is to import all the useful libraries and their methods. And here we are just loading the dataset into Xtrain and Ytrain. And here we are just normalizing the images. So it will be in 0 to 1.0 range. So it will be very easy for data model to map those values. And this is, we are just encoding our labels using one hot encoding. And if you go down, so this part here, we need to add some dropout layer, max pooling layer in our model, which was given by the professor. So if you see in the model, we have the convolution 2D layer, then we have a dropout, and 20% will be dropout, the neuron. And then at the end, we are flattening the layer. And if you see the very end layer, there is a dense 10. So this hyperparameter telling us there are 10 classes, and we have an activation softmax that is nonlinear activation function used for multiple classes. And here we just configure our model with the learning rate, and then we compile the model. And you can see the summary of our model here. And this is a simple image. Then we fit the model with our X train and Y train. And here you can see the accuracy of our model is 78.15%. So the simple model had only 60% accuracy. Now it increases to 78%. So if you go down, this is the okay, that's fine. Okay, the next task was change the sequential model into API model. So we did not, so model is same. We just assign the variable to each layer and multiplying the previous layer with the next layer and get the output. So that's what we are doing in the API model. So if you go down, Zakaria, and then we compile the model. This is our configuration of the model. We are giving categorical cross entropy because we have multi-class problem. And if you go down, this is the summary of our model. And then we just fit the model and we got the accuracy of 90%. So there 0.09%, 0.09 accuracy. So if you go down, then we have a model checkpoint, which is an early stopping. So this is the method if your model is not improving after each iteration, then it will stop your model. That will cause your overfitting if you train your model too much. So we have early stopping method, which have a monitor. We are monitoring validation loss, and this is a mod minimum. And we have a patience 200. So what it will do, it will wait for 200 epoch. If the model won't improve until 200 epoch, it will stop the training and it will give you the result. Then we
Uh,
have with fit the model, and that's it. So
okay, so
next, Zakia will continue from here.
yeah, so next we were asked to predict four classes from for to basically give four images to our model and let it predict. So the whole here for loop is basically running four times for four images, and all it is doing is basically gaining the maximum. Like remember in our last ICP, we also did the our ARG max function. We use the ARG max to return the index of our maximum neuron. So here, for example, predicted value for image one is it comes in a matrix form, and you have to take the maximum value and the index at the maximum value. So that basically that means that that particular neuron is firing. So here it's class 3 and it's linked to class 3. This was linked to class 8. This is linked to class 8 as well. And image 4 is linked to class 0. So that's how it went. And the next task we were actually given to create a data set on our own. So we basically loaded cats and dogs images. So there were around 10,000 plus images for cats and dogs. And we had to initially rescale them and reshape them so they were coming in different shapes. For that purpose, okay, so initial step was to just to load and present one image of cat and dog. Next, we are trying to read their sizes and shapes for dogs and cats, and then we use image generator function just to rescale them and then reshape them. Here we're basically reading our directory of training set and testing set, and then just giving it the desired path. So our class is basically divided into cats and dogs. That's what we have to predict. So we created a small, simple sequential model having convolution layers, max pooling, flattening, and let's see its accuracy and validation accuracy. How does it work? So initially we have set it only 10 epochs, and we are having a huge amount of loss. The model is not performing well, and the accuracy is almost near to null. So the possible reason is because we haven't the pictures are just rescale, and they haven't been any pre-processed, or they haven't gone through any much of the steps. Other than that, we had to basically implement early stopping and model checkpoint. So early stopping is implemented here, and model checkpoint is implemented here. And then we had to save that model in the path given. Yes. So we're done with that. Thank you, everyone. Stop recording.